Today we're going to talk about Cartesian coordinates and converting them to polar coordinates, but mostly learning how to map things in the polar plane. Let's talk about the Cartesian plane first. Fancy word for the XY plane. Now, if I wanted to take and graph the point 3, 5, I'd simply move over on the x3, up on the y 5, and graph that point. Now when we talk about polar coordinates are given in the form of a radius followed by an angle. So the graphing of that is just a little bit different. You're going to go out a certain distance and then around in that certain angle, which means you need a different type of coordinate system or coordinate axes to be able to graph this. And what that's going to look like is this. So you'll see that I have a bunch of concentric circles starting from the middle, and these concentric circles have radii of 1, so each of these new circles is a larger radius of 1 in value. And then we have our degree measures marked around the circle. So I have a number of different points that I'm going to graph. Let's call this A, B, C, and D. And we'll graph the point 5 and 30 degrees first. So we'll graph the point A. So I go out radius of 1, 2, 3, 4, 5, and around 30 degrees, which puts me here. So that's my A point. If I wanted to go 2 and negative 170, well, here's my radius of 2, and then I'm going negative 170 degrees, so I know I'm going clockwise, and that's going to put me right here, 10 degrees short of 180, and we'll call that B. If I have negative 3 and 20, I think we talked about this a little bit before in terms of vectors. The same applies here. The negative radius means travel 180 degrees more, or go in the opposite direction. So really what we have is we have a 3 and a 20 plus 180 degrees. So in this case, we'd go out 3, 1, 2, 3, and we'd go around 200 degrees. So that puts us here. And that's C. Lastly, we have negative 4 and 60 degrees. So once again, we add the 180 degrees to that, and we have negative 60 plus 180 gives us 4 and 120 degrees. So we go out a total of 4 in radius, 1, 2, 3, 4, and we go to 120 degrees. So I'm out 1, 2, 3, 4. Plop the point down, and that's our point D. All right. Now there are some other things we're going to take a look at. You'll notice this problem asks us to name the point negative 2 and negative 150 three other ways using positive and negative values for r and theta. And we have to keep our theta values between negative 360 and positive 360. If we look back at our previous example, you'll notice we graphed the point B of 2 and negative 170, and that was right here, but you'll notice that ends up at 190 degrees. So for this case, 2 and 190 is the same point as 2 and negative 170. It's not the same angle, obviously, because you've gone a different direction, but it is the same point. So it's kind of like where a coterminal angle ends. So here's what we'll do. we'll take and graph -2 and 150 and see where that lands. Well, we know to be at a negative radius, we have to add 180. So that gives us 2, and -150 plus 180 gives us 2 and 30 degrees. Well, 2 and 30 degrees puts us somewhere, if I go around, somewhere here. All right. Now, we started by saying this is the same as -2 and -150, but we've also just found out that it's equivalent to 2 and 30 degrees. So this is one of the ways to do that. Now, if I wanted a positive angle measure, and between 0 and 360, this is pretty much the only place I can do it, unless, of course, I have a negative radius that adds 180 degrees to get me back to that 30 point. All right, or subtracts 180 degrees, doesn't really matter. So I know that 30 degrees away from 180 is 210. So what I could do is I could say, well, if I had -2 in radius and 210 degrees, that would put me at either adding 180 or subtracting 180 from 270, or from 210, sorry. So that gives me, again, my 2 and 30 degrees. Lastly, if I want to name a positive radius and just go in a negative direction, 30 degrees short of 360 is 330. So I've got my 4 ways of naming the point -2, -150, all ending up at this point, which is really 2 and 30 degrees. Now, in the Cartesian plane, which is just the xy axis, I want to graph the following lines. So the first one's going to be x is equal to 5. So I locate my 5, and I know x equals means x has to be the same everywhere on this line. If I take this point, that's like 5 and let's say 4. If I take this point here, this is 5 and -3. So 5 is the consistent point on this line. Doesn't matter what y is. And that's our graph of x equals 5. Now, if I want y equals -1, find -1, which is right around here, and the y value always has to equal -1. So let's align something like this. Now, we can do the same in terms of polar coordinates. So if I want my radius to always be 4, well, where will my radius always be 4? Well, I know 1, 2, 3, 4. The radius is 4 here. And the only place the radius is always going to be the same is on a circle of that same radius. So if I take and draw a circle around the circle of radius 4 in this case, that gives me r equals 4 as a graph. If I want my angle to always be 35 degrees, then I find out where 35 is, which is somewhere here-ish, and I make my angle 35 degrees. Thus, my radius doesn't matter, so what I really have is a straight line. And if I want my angle to be 35 degrees, my radius could be negative, so that would just flip that guy over. Let's see if I can draw a straight line between 30, so it's somewhere here-ish. And that's my angle of 35 degrees. Now, this last problem, a little bit different. I want to locate the point 7 and 20 degrees, which is somewhere around 1, 2, 3, 4, 5, 6, 7, 20 degrees. And I want to locate the point 2 and 115. So 2 out, 115 up, 115 somewhere right around here. 2 is going to be somewhere right around here. And I want to take and find the distance between those 2 points. So basically, I'm saying how long is that segment right there? Well, the book shows us one way to do this. I like doing it another way. What I prefer to do on a problem like this is say, well, what if I did this? What if I take and say, if I was to connect that dot to the origin and this dot to the origin, I've created a triangle. And in that triangle, I know that I have an angle formed here that's basically the difference of 115 and 20, so 95 degrees. And then I also have some lengths. I know that this length is 7 and this length is 2. If I want to find my missing value, x here, that x corresponds to the distance between the 2 points I was given. This is a perfect setup for the law of cosines. And the law of cosines states if I have an unknown side opposite some given angle, then that's equivalent to 2 squared plus 7 squared minus 2 times 2 times 7 times the cosine of that angle opposite. Whoops, 25 degrees. And now it's just a calculator problem. And then after grinding all that out, we get x is equal to roughly 7.44. And that's the way I do this problem. I think it's the easiest way. The book kind of convolutes things a little bit, but I'd go in this direction. That's all we've got for you today. Answer these questions. We'll see you tomorrow.